Hello students, I am Sasitakar. Welcome to Cars Physics. In this lecture we will discuss relative velocity in two dimensions. Okay. In previous lecture we have discussed relative velocity in one dimension and also we have discussed some numericals based on relative velocity in one dimension. In this lecture, we will discuss relative velocity in two dimensions. Okay, means in two dimensional motion, and best example of relative velocity in two dimensional motion is rain and man. Okay, rain and man. Okay, let's discuss. And we will go through the fundamental, thereafter we will approach numericals. Okay. As you know, suppose a body moving with velocity v and another body b moving with velocity vb and angle between these two velocities is theta, then relative velocity of body A with respect to body B is calculated as v minus vb. Okay, we have discussed in just previous lecture. Relative velocity is calculated by the method of vector subtraction. Why? In previous lecture, I have told you, I will answer why relative velocity is calculated by taking the method of vector subtraction. This is your answer. Okay. So, vector subtraction, as you know, VA minus VB can be written as VA plus minus VB. Means in vector subtraction, negative of one vector is added with other vector. Suppose we have to calculate velocity of A with respect to body B or velocity of A with relation to body B. Then who is observer? Who is observing? Observer is B. Velocity of body A as observed by body B. The basic concept, the observer should be at rest. Who observes? Who observes is observer, and observer should be at rest. But here both are in motion. So we have to assume that the observer is at rest. So what is the vector diagram? As you know, suppose this is direction of V, body A is moving along this direction and body B is moving along this direction. This is velocity of body B and angle between them is theta. So observer is B. Okay. So what is meaning of VA minus V? Means VA plus minus V. This is the method of vector subtraction. If this is VB, then length of this line, straight line, represents magnitude of VB. Arrow mark represents direction of VB. If same straight line, same length of line is produced in opposite direction, then this represents minus VB. See, upward VB and in opposite direction, this is also VB. Angle between VB and this VB is 180 degree. Thus, resulting velocity of body B is taken to be 0. VB plus VB is 0. Same magnitude but opposite in direction. So body B is taken to be at rest, but practically body B is in motion. Okay. Then as per method of vector subtraction, we have to complete the parallelogram, and this is diagonal, and diagonal represents resulting velocity, means relative velocity VA. Okay. Then this angle is 180 degree minus theta and this angle is alpha. You know, magnitude of VAB is equal to square root of VA square plus VB square plus 2 VA VB cos 180 degree minus theta. This is a formula for resulting vector in vector subtraction, and to know direction tan alpha. Alpha is angle made by relative velocity, means resulting velocity VAB with VA, then the formula VB sine 180 degree minus theta divided by V plus VB cos 180 degree minus theta. Okay. This is generalized method. Of course, you can solve this formula by taking the help of orthogonal unit vectors, means I cap, j cap and k cap. We will see in numerical. Okay. Now, let's direct go to numericals based on rain and man. Rain and man, this is your basic method, what I have already discussed in previous lecture. This formula is applicable for both one-dimensional and two-dimensional motion. For one-dimensional motion, angle between VA and VB should be either 0 degree or 180 degree. But in two-dimensional motion, the angle may be other than 0 degree and 180 degree, means any value between 0 and 180. Okay. Then rain and man. Let's see the basic concept. You just think. Suppose rain is falling. Suppose. The basic concept is let's neglect resistance of air. Air resistance is neglected. Okay. If air resistance is neglected, then let rain is falling in vertically downward direction. Okay. The first concept, rain is falling in vertically downward direction. With a velocity VR. VR is velocity of rain, and a man is standing. Okay. A man is standing and rain falls in vertically downward direction. Okay. Then to save himself from rain, if rain is falling in vertically downward direction, then to save himself from rain, the man should hold umbrella in vertically upward direction. Rain is falling in vertically downward direction and the man is stationary, means standing. To save himself from rain, the man should hold umbrella straight in upward direction or in vertically upward direction. Okay. We know it. If you want to prove it, let's discuss. Suppose velocity of rain is 5 meter per second in vertically downward direction. Let's take this is x-axis and this is y-axis. Rain is falling in vertically downward direction. Rain is falling in vertically downward direction. This is velocity of rain. And man is standing. Man is standing. Okay. Then in what direction he should hold the umbrella to protect himself from rain? In vertically upward direction. Let's prove it. In this case, we have to find velocity of rain with respect to man. Okay. Velocity of rain with respect to man. Then who is observer? Rain can never be an observer. Rain can never be an observer. Can rain observe? No. Man is observer. So velocity of rain with respect to observer means with respect to man. And as per our formula of vector subtraction, this is Vm minus Vm. Okay. Method of vector subtraction. So rain falls in vertically downward direction and magnitude of velocity of rain is 5 meter per second, means here in vector form. If you take the help of orthogonal unit vector, this is along negative y-axis direction. So velocity of rain is 5 into minus j cap meter per second. And velocity of man is 0 because man is standing. Then relative velocity means velocity of rain with respect to man is Vr minus 5 j cap. Velocity of man is 0. Then velocity of rain with respect to man is minus 5 or 5 minus j cap meter per second. So rain is falling with a velocity 5 meter per second, but direction is in negative y-axis. To save himself from rain, the man should hold the umbrella in vertically upward direction. So whatever rain strikes on his umbrella will not fall on him. So he is saved from rain. Okay. Now let's take motion of the man. Okay. This is basic case. You can just imagine. In the help of orthogonal unit vectors I cap, j cap, we can do also the numericals are where it is required, but in direct form, taking the method of vector subtraction, we can solve the numericals. Okay. Next question. Question number 2. Actually, this is question number 1. Rain is falling in vertically downward direction with a velocity Vr. This is like 3 meter per second, and a man is moving horizontally with a velocity of 4 meter per second. Horizontally, you may take either along positive x-axis direction or in negative x-axis direction. This is y-axis. Rain is falling in vertically downward direction. Let's represent first. This is velocity of rain in vertically downward direction, and man is moving horizontally. Let's take motion of man along positive x-axis. Man is moving horizontal with a velocity, means velocity of man, is Vm. Vm is equal to 4 meter per second. You may represent here, a man is moving in horizontal direction and rain falls in vertically downward direction. This is velocity of rain and this is velocity of man. Okay. So representing velocity of man along positive x-axis and velocity of rain along negative y-axis. Our form is to calculate velocity of rain with respect to man. Then what we have to do? Velocity of rain with respect to man can be calculated by taking method of vector subtraction Vr minus Vm or Vr plus minus Vm. Okay. Then negative of velocity of man is added with velocity of rain. If this is Vm, then in opposite direction produce same straight line, same length of line. This is minus Vm. This is also 4 meter per second, and this angle is theta, means theta is 90 degree. Then we have to get resultant of Vr plus minus Vm. This is minus Vm, this is Vr. And these two, Vr and minus Vm, are along two adjacent sides of a parallelogram. Then this diagonal represents the R. Okay, this is vertical line. Rain falls in vertically downward direction, and this is direction of velocity of rain with respect to man, means rain appears to fall. Rain appears to fall in this direction. Okay, making an angle alpha with vertical. Then our aim is to calculate magnitude of relative velocity and direction of resultant relative velocity. See, here the angle is, this is theta. Then magnitude of Vrm is square root of Vr square plus Vm square plus 2 Vr Vm cos 180 degree minus theta, here theta is 90 degree, and cos 180 minus 90 is cos 90. Cos 90 is 0, 0 into anything is 0, then magnitude is square root of Vr square plus Vm square. And Vr, magnitude of velocity of rain is 3 meter per second, 3 square. Magnitude of velocity of man is 4 meter per second, 4 square, and this is 5 meter per second. So relative velocity is 5 meter per second, magnitude of relative velocity is 5 meter per second, and this angle is alpha. This angle is alpha. See, length of line represents magnitude. If this is 4 meter per second, this is also 4 meter per second, and this is velocity of rain. Magnitude of velocity of rain is 3 meter per second. Then in this right angle triangle, this angle is 90 degree, then tan alpha is equal to perpendicular upon base. Perpendicular is 4, base is 3, tan alpha is 4 by 3, and you know the simpler form forward. Okay. This is 4 meter. This is 3 meter. This is 3 meter. This angle is 90 degree. Then this angle is theta. Okay. And obviously, if this is 3, this is 4, this angle is 90 degree, then this is 5 meter. Then here, tan theta is 4 by 3. Means theta is equal to 53 degree. Okay. Then tan alpha is equal to 4 by 3, then alpha is 53 degree. Then rain appears to fall in this direction, making an angle alpha, Then to save himself from rain, the man should hold the umbrella, making an angle alpha with vertical. Means he should hold the umbrella like this. This is vertical line, and this angle is alpha. Here alpha is 53 degree. And you have observed, if rain actually falls in vertically downward, and if you run or if you move, walk, then you have to hold the umbrella, making an angle with vertical. This angle is alpha, making an angle with vertical. So this angle is, in this case, 53 degree. This is generalized method. Of course, if you want to solve it taking orthogonal unit vector, then you can also adopt the method. Is it clear? Is it clear to all? Okay. Then another method means orthogonal unit vector, taking the help of orthogonal unit vector. If you find easier, you can follow it. This is, I think, this is also easier method. Rain is falling in vertically downward direction. This is velocity of rain. Okay. Magnitude of velocity of rain is 3 meter per second along negative y-axis. Man is moving horizontally. Let's take along x-axis. This is velocity of man. Velocity of man is 4 meter per second. 4 meter per second. This is 4 meter per second. And as we know, velocity of rain with respect to man is Vr minus Vr. See, here Vr is along negative y-axis, 3 meter per second, 3 into minus j cap, minus velocity of man, 4 into I cap. 4 into I cap, then this comes minus 3 j cap, minus 4 I cap, then magnitude of relative velocity is angle between j cap and I cap. This is minus j cap, this is I cap, angle between them is 90 degree, then magnitude is square root of minus 3 square plus minus 4 square. Again this is 5 meter per second, the same answer, then about direction. This is minus V. This is vertical line. This is minus V. minus V. Complete the parallelogram. And this is the direction of relative velocity VRA, and this angle is alpha. So magnitude of velocity of man is 4 meter per second. Again the same thing, this is 4 meter per second, this is 3 meter per second, this angle is alpha and this is 90 degree. Again tan alpha is equal to perpendicular upon base 4 by 3, theta is 53 degree. Then the man has to hold umbrella in opposite direction to save himself from rain. Rain is falling at an angle alpha means 45 degree. At an angle alpha means 53 degree with vertical. Rain is falling like this. Then the man has to hold the umbrella like this. You must adopt any one of the method. Okay. Then the question will come from now. Okay. Question will come from now. Next question. Now we are going to approach some application questions and easier questions. Next question. A man is moving horizontally with a velocity of 4 meter per second when rain appears to fall in vertically downward direction with a velocity of 3 meter per second. Find actual velocity of rain. Find actual velocity of rain. Just think about the concept. Rain falls and rain appears to fall. Rain falls and rain appears to fall. Man is moving horizontally with a velocity 4 meter per second and rain appears to fall. I have not written rain falls. Rain appears to fall. I have already told you what is meaning of appears to fall. Appears to fall means relative velocity, means velocity of rain with respect to man. This is not actual velocity of rain in vertically downward direction. Rain appears to fall in vertically downward direction. Then we have to find what is actual velocity of rain. Okay. Again, this question can be solved in generalized way, and also this can be solved by taking the method of orthogonal unit vectors I cap, j cap and k cap. Okay, let's see. Man is moving horizontally. Man is moving horizontally. This is velocity of man. Rain appears to fall in vertically downward direction. Means this is VRA. This is VRA. Rain appears to fall in vertically downward direction. Then we have to find what is actual velocity of rain. Okay. See. Man is moving horizontally. Let's take along positive x-axis. This is velocity of man. We have taken the magnitude of velocity of man 4 meter per second. Man is moving horizontally with a velocity 4 meter per second, and rain appears to fall in vertically downward direction. So what is this? Rain appears to fall in vertically downward direction. Then this is velocity of rain with respect to man. This is the concept. Then what is your basic concept in generalized method? VRM is equal to VR minus VM or VR plus minus VM. Method of vector subtraction is equivalent to method of vector addition. Only negative of one vector is added with other vector. Means to get VRM, we have to get first minus VM. This is minus VM. This is VR. Sum of minus VM and VR gives us VRM. Then add these two. Complete the parallelogram, and this is VR. Is it correct? No. This is wrong. Rain appears to fall in vertically downward direction. Then what is actual velocity of rain? See, if you are taking parallelogram law, then minus Vm and Vr, minus Vm and Vr should be along to adjacent sides of the parallelogram, and Vrm is a diagonal of the parallelogram. The simplest way. Also, I will show you taking orthogonal unit vectors I cap, j cap and k cap. See different methods so that your concept will be clarified. Vr and minus Vm, adding these two we will get Vrm. So if you use parallelogram law, these two should be along to adjacent sides of parallelogram, and Vrm is a diagonal. Then what you have got? You have got one adjacent side of parallelogram and diagonal of parallelogram. Obviously, this is another adjacent side of parallelogram. This is Vr. Now complete the parallelogram. See, minus Vm plus Vr minus Vm plus Vr is equal to Vrm. Vrm is a diagonal. Okay. Now we have to calculate actual velocity of rain, means we have to calculate Vr. Very easy. Okay. Magnitude of Vm is 4 meter per second. This side, length of this side is equal to length of this side. This is Vr. If this is 4 meter per second, length represents magnitude. This is also 4 meter per second, and rain appears to fall in vertically downward direction with a velocity 3 meter per second. Then obviously this angle is 90 degrees. Simply apply Pythagoras theorem. This is 90 degree, this is base, this is perpendicular, and this is hypotenuse. Then magnitude of velocity of rain, means actual velocity of rain, is square root of 3 square and 4 square. This is 5 meter per second. And accordingly, you can calculate direction of actual velocity of rain. If this is alpha, then tan alpha is equal to perpendicular upon base, means 4 by 3, then alpha is 53 degree. This is magnitude of velocity of rain, actual velocity of rain, and this is direction, means velocity of rain, actual velocity of rain falls making an angle 53 degree with vertical. Do you want to solve it taking orthogonal unit vectors? Okay. Again the same answer will come. See, Vrm is equal to Vr minus Vm. See, Vr, we have to calculate Vr. Vrm, this is direction of Vrm. Vrm is 3 meter per second along negative y-axis. Then this is 3 into minus j cap. This is negative y-axis. 3 into minus j cap is equal to Vr minus Vm. Vm is along positive x-axis. Magnitude of Vm is 4 meter per second. Then this is 4 I cap. Then this is 4 I cap. Then Vr is equal to 4 I cap minus 3 j cap. 4 I cap minus 3 j cap. Then magnitude of Vr, see, angle between I cap and j cap is 90 degree. Then obviously magnitude is square root of 4 square plus 3 square is equal to 5 meter per second. Okay, and direction, about direction, this is VR, about direction. If you got vector form of VR, this is I cap, this is J cap, then this is direction of J cap, negative the y axis, and this is direction of I cap, then this angle is alpha, then tan alpha is equal to P perpendicular upon base, means 4 divided by 3, again alpha is 53. Clear? In this method or in this method, whatever method you feel easier, do this. Okay? Rain appears to fall in vertically downward direction. We do calculate the actual velocity of rain. Now I will curl this question. This question will be curled. And I am writing the question, just enjoy it. Just enjoy it. Conceptual question, and I hope you will have interest on this question. Okay. A man is moving horizontally with a velocity of 10 meter per second when rain appears to fall in vertically downward direction. If the man doubles the magnitude of his velocity, then rain appears to fall at an angle 45 degree. Calculate actual velocity of rain. Beautiful question. Pause the video and try it once. Pause the video and try it once. A man is moving horizontally with a velocity of 10 meter per second and rain appears to fall in vertically downward direction. Now the man doubles the magnitude of his velocity and rain appears to fall at an angle 45 degree. Then what is actual velocity of rain? Beautiful numerical. And this can be solved only by taking vector diagram without any confusion. Let's represent only vector representation. This is easier. See, man is moving horizontally. Let's take along positive x-axis. This is initial velocity of man, Bm1. Magnitude is 10 meter per second. When man moves horizontally, then rain appears to fall in vertically downward direction. This is Vrm in first case. Vm1, and rain appears to fall in vertically downward direction. And as per our general concept, Vrm is equal to Vr plus minus Vm. Okay? Vrm, relative velocity of rain with respect to man, is equal to Vr minus Vm, Vr plus minus Vm. Just use this, the vector diagram, you will solve it easy. So, first let's consider the first case. Man is moving in horizontal direction, rain appears to fall in vertically downward direction. Then to have relative velocity, we have to add minus Vm with Vr. If this is Vm1, then in opposite direction produce same straight line, same length of line, then this is O, this is A. OA represents minus Vm1. Okay, this is minus Vm1, minus Vm, Vrm, minus Vm and Vr. If you follow parallelogram law, then minus Vm and Vr should be along two adjacent sides of a parallelogram, and Vrm is a diagonal. See, if this is diagonal of parallelogram, this is one adjacent side of parallelogram, minus Vm here, minus Vm1, then obviously this is another adjacent side of parallelogram, which is Vr. Complete the parallelogram. Complete the parallelogram. Let's think. Vr minus Vm1 is equal to Vrm1. Just put here 1. This is 1. Okay. Vr plus minus Vm1 is equal to Vrm1. This is first case. In next case, if the man doubles his velocity, this is A dash. OA dash represents Vm1. If the man doubles his velocity, length represents magnitude. The man has doubled the magnitude of velocity, but direction is same. Then this is B dash, and this represents Vm2. Means OB dash represents Vm2. This is 10 meter per second. This is also 10 meter per second. Thus velocity is doubled. If man doubles the magnitude of velocity, then rain appears to fall at an angle 45 degree. Man is moving along positive x-axis direction, and rain appears to fall at an angle 45 degree. You may take this angle is 45 or this angle is 45. So this is Vrm2 in second case. To have Vrm2, we have to add Vr vector plus minus Vm2 vector. This is minus Vm1 vector, thus double the length of line. Double the length of line because magnitude is doubled. This is Vm2, this is OB, means OB represents minus Vm. Okay. Now, this is the case of, this is the first case, Vr minus Vm and Vrm1. Then second case, this is minus Vm to OB. OB represents minus Vm2. Okay. Then minus Vm2 and Vr. These are two adjacent sides of a parallelogram, and this is diagonal. Complete the parallelogram. Okay. If you name, this is C, this is D. Then for first case, the parallelogram is OA. Let's take this is E. OAED. For second case, the parallelogram is OBCD. For second case, parallelogram is OBCD. See, this magnitude is 10 meter per second. This is double. This is also 10 meter per second. If this is 45, this is 90. This is also 45. So this is also 45. This is also 45. This angle is 90. Now it is easier. Just see the diagram. This is for first case, and the total parallelogram OBCD for second case. For second case means when the man doubles his velocity. Okay. So this is 45. This is 45. This length means OE. represents VRM1. Okay, this represents VRM1. Okay, on VM1, this is VM1 10 meter per second, this length represents 10 meter per second, then this point is E, then ED, length of ED also represents 10 meter per second, this is 45, this is 45, then obviously OE also representing the magnitude of 10 meter per second. This is 45, this is 45. If ED is 10 meter per second, this is 10 meter per second, this is 10 meter per second, then this is also 10 meter per second. So OED, this is E. OED is isosceles triangle. This is 45, this is 45, this is 10 meter per second, this is 10 meter per second. Then OD represents magnitude of VR, then obviously OD means VR, magnitude of VR is square root of, this is 90 degree, this is base, this is perpendicular, this is hypotenuse, this is 10 meter per second, this is also 10 meter per second, then square root of 10 square plus 10 square is equal to 10 root 2 meter per second. 10 root 2 meter per second, and angle is clear, making an angle 45 degree with vertical. Man is moving along this direction and rain is falling at an angle 45 degree with vertical. Rain is falling like this, making an angle 45 degree with vertical or with horizontal, same thing. Is it clear? Is it clear? Then again we will approach some conceptual numericals. Next question. Next question. If it is not clear, go through the video, pause the video and think, and then proceed and draw the vector diagram. It will be clear. Don't think difficult. These are required for you. The next question. I am going to next question. Suppose one of the question I have with me okay. Suppose this is a horizontal road. A man is moving horizontally with a velocity of man is 4 meter per second. Velocity of man is 4 meter per second when rain falls like this. Rain falls like this means making an angle. This is velocity of rain. This is velocity of rain. This is velocity of rain. Making an angle 37 degree with horizontal. Okay. Then the question arises, what is the relative velocity of rain with respect to man, and at what angle the man should hold the umbrella? Okay. Of course, man should hold the umbrella opposite to the direction of velocity of rain. Okay. Man is moving horizontal with a velocity of 4 meter per second. Rain falls at an angle 37 degree with horizontal. Okay. Then how can you solve it? Velocity of rain is 4 meter per second. This is along positive x-axis. I may take 4 I cap meter per second. Then about velocity of rain. This is velocity of rain. This is along x-axis. This is along y-axis. Then component of velocity of rain. Okay, a value should be assigned. Let velocity of rain, let's take 5 meter per second. Okay, this angle is 37 degree. Then component of VR along x-axis is 5 cos 37 degree, and component of VR along y-axis is 5 sine 37 degree. Then in vector form, VR is equal to 5 cos 37 degree along positive x-axis I cap plus this is Vx, this is Vrx, velocity of rail along x-axis, this is velocity of rail along y-axis, Then this is 5 sine 45, 5 sine 37, 5 sine 37, direction is minus theta. This is along x-axis, this is along negative x-axis, negative y-axis. And you know, don't forget the triangle rule. This angle is 37, then this is 3, this is 4, this is 5. Tan 37 is 3 by 4, just remember it, and from this you can calculate sine and cos there. Then VR is equal to 5 cos 37. Cos 37 is 4 by 5 into I cap plus 5 sine 37, this is 90 degree, perpendicular upon hypotenuse 3 by 5 into minus theta. Then velocity of rail is equal to 5 4 I cap 5 this is minus 3 j. And velocity of man is 4 I cap. Then to get velocity of rain with respect to man, we have to take VR minus VR. In place of VR we can write 4 I cap minus 3 j cap minus velocity of man is 4 I cap. Then solving it, 4 I cap minus 4 I cap 0. Then resulting VRM is equal to minus 3 j cap. Means rain will appear to fall in vertically downward direction, means this is 3 into minus j cap meter per second. Minus j cap means along negative y-axis, this is 3 meter per second. Then in this case, the man can save himself by holding the umbrella in vertically upward direction, because 3 into minus j cap means rain appears to fall in vertically downward direction. So the man should hold the umbrella in vertically upward direction to save himself from rain. Is it clear? Very easy question. Okay. Next question. Next question about inclined plane. See, suppose this is an inclined plane. You may consider a cyclist. Cyclist is moving on the inclined plane. We will assign some velocity. This is velocity of man moving up the plane. Angle of inclination is theta. We may take any value. Suppose we may take 37 or 53 degree. Angle of inclination is 53 degree, and rain falls in this direction. This is velocity of rain, this is velocity of rain. So making an angle with horizontal, let's take this angle 37 degree. This angle is 37 degree. Rain is falling at an angle 37 degree with horizontal. Then in this case, we have to find relative velocity of rain with respect to man. Okay. Then in this case we have to find rectangular components of the velocities. First let's take velocity of man. See, man is moving along this direction. Let's represent this is velocity of man. This angle is 53 degree. Okay. Then horizontal component is Vm. We may assign a velocity. We may take a value of velocity of man. Let's take this is 10 meter per second. And velocity of rain, you may take 5 meter per second. Any value you may assign. This value is 10 meter per second. And this is Vm, velocity of man along x-axis. So this is 10 cos 53 degree. And the vertical component of velocity Vmy, this is 10 sin 53 degree. 10 sin 53 degree. Then velocity of man in vector form we may write velocity of man along x-axis plus velocity of man along y-axis. So velocity of man is equal to Vmx 10 cos 53 degree. Direction is along x-axis I cap. Then this is along y-axis 10 sin 53 degree. Direction is j cap. Again, don't forget this triangle rule. Oh. If this angle is 53 degree, then this is 4 meter, this is 3 meter, and this is 5 meter. Then velocity of man is equal to 10 cos 53. Cos 53 is, this angle is 90 degree, base upon hypotenuse 3 by 5 into I cap plus 10 into sin 53 perpendicular upon hypotenuse 4 by 5 j cap. Then velocity of man is equal to, this is 2 into 3, 6 I cap. This is 2 into 4, this is 8 j cap. This is vector form of velocity of man. Then about velocity of rain. Velocity of rain, see, rain is falling along this direction. This is velocity of rain. This angle is 37 degree. Okay. This is velocity of rain along x-axis. We may take this is Vr cos 37. Direction is minus I cap. This is vertical component. Velocity of rain along y-axis. This is Vr sin 37 degree into minus. Then Vr in vector form. Velocity of rain is 5 meter per second, 5 cos 37, 5 cos 37 minus I cap plus, this is also 5 sin 37 into minus 3. So velocity of rain is equal to 5, again 37 degree. You may again follow the triangle rule. This is 37 degree. This is 3 meter, this is 4 meter, this is 5 meter. Okay. Then 37 is 3 by 4, tan 53 is 4 by 3. Then cos 37 is base upon hypotenuse 4 by 5 into minus I cap. 5 sin 37 is perpendicular upon hypotenuse 3 divided by 5 into minus 3. 5, 5, 5, 5. Then velocity of rain in vector form minus 4 into I cap. This is also minus minus 3 into jk. Then now conclusion, velocity of rain with respect to man, velocity of rain with respect to man, Vr minus Vr. Then velocity of rain with respect to man, Vr, where we have got it, minus 4 I cap minus 3 j cap minus velocity of man here 6 I cap plus 8 j cap, 6 I cap plus 8 j cap. Then solving it will get velocity of rain with respect to man, C, minus 4 I cap plus 6 j cap means 2 I cap, minus 4 I cap plus 6 I cap plus 2 j cap minus 3 j cap minus 8 j cap minus 3, or you may open it, Vr is equal to minus 4 I cap minus 3 j cap minus 6 I cap minus 8 j cap. Okay. Then Vrm is equal to 4 I cap minus 6 I cap minus 10 I cap, 4 minus 6, okay. Then minus 3 j cap minus 8 j cap 11 j cap. This is vector form of relative velocity. Again you can calculate Vr, magnitude of Vr between I cap and j cap angle is 90. You can calculate it 10 square plus 11 square root over meter per second. Then about direction of Vrm, relative velocity 10 I cap. This is 10 I cap minus 10 I cap and this is minus 11 j cap. Then this will be direction of Vrm. Okay. You may take any angle. Let's take angle with vertical. This angle is alpha. This angle is alpha. Length represents magnitude. This is 10, this is 11. Then obviously tan alpha is equal to 10 divided by 11, and alpha is tan inverse 10 divided by 11, and the magnitude you may calculate from this minus 10 I cap minus 11 j cap. Okay. Minus 10 I cap minus 11 j cap. I think what you have given, your answer is not matching. Let me see again. 10 meter per second you have given, man is moving with a velocity 10 meter per second. Angle of inclination you have given 53. Yes, this is correct. Velocity of rain you have given 5 meter per second. Of course, you can take any value. And angle with horizontal is 37. Then velocity of rain 4 I cap minus 4 I cap minus 3 j cap. This is also correct. Then velocity of man, let's check it once. Velocity of man 10 cos 53 I cap plus 10 sin 53 j cap. Then cos 53 is 3 by 5. This is 2, this is 3, 6 I cap. Okay, this is also correct. And this is 2 into 4. This is 8. This is also correct. Okay. This one is right. Calculation is correct, but I think you have not written the answer properly. Okay. This is about the relative velocity in two-dimensional motion part 2. In next lecture, again we will discuss relative velocity in two-dimensional motion part 3. River and boat or river and swimming man. Thanks my children. Thanks.